Finally, we have the power rule. If you raise an exponent to another power, what happens? 3 squared to the fourth would be 3 squared times 3 squared times 3 squared times 3 squared. And that would be 3 times 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 3. Using the definition of an exponent, that gives us 3 times 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 3 equals 3 to the 8th. We equate the two. 3 squared to the fourth equals 3 to the 8th. And our general rule will be a to the m to the nth is a to the m times n. When you raise an exponent to another power, you multiply the exponents together. Let's try another example, maybe 4 squared cubed. Our rule says that that should be 4 to the 2 times 3 equals 4 to the 6th. If we look on a calculator, 4 to the 6th is 4096. 4 squared is 16. 16 cubed is 4096. Now we can go through this discoveries and observations section. An exponent of 1 is just the number itself. Using the definition here, we have 2 times 2 times 2 times 2 times 2, 5 of them, divided by 2 times 2 times 2 times 2, and 4 cancel. And that just leaves us with 2. With the quotient rule, 2 to the 5th divided by 2 to the 4th is 2 to the 5 minus 4, and that's 2 to the 1. So 2 equals 2 to the 1, and the general rule is that a to the 1 equals a. And I don't think we need a calculator to verify this, but if you plug in anything to the power of 1, the calculator should give you back the same number. 1 squared is 1 times itself. That will be 1. 1/3 is just 1 times 1 squared, which is 1 again. 1 to the 4th will be 1 times 1 cubed. So that would tell us that 1 to the n is 1. Multiplying anything times 1 is itself. 1 is called the multiplicative identity. 0 times 0 is 0. 0 cubed will be 0 times 0 squared, which is 0. 0 to the 4th times 0 cubed will be 0. And so 0 to the nth must be 0. It's just 0 times 0 times 0 n times. Use the product rule and the negative exponent rule to confirm the quotient rule. Well, remember that the product rule is a to the m times a to the n equals a to the m plus n. And remember that the negative exponent rule says that a to the negative m equals 1 over a to the m. They've set it up for us. A to the m minus n equals a to the m plus negative n. And by the product rule, that equals a to the m times a to the negative n. And by the negative exponent rule, that equals a to the m times 1 over a to the n equals a to the m over a to the n. And you see, this is the quotient rule. Is there a sum rule? 3 to the fourth is 81, plus 3 squared is 9. That would give us 90. How can we make 90 into a single number to an exponent? Well, there are ways, but I can't think of any obvious integers that would make a to the m equal 90. And you can see that the rule wants the same base, so we need some power of 3 to equal 90. We would have 3 to the m equal 90. And that's not going to be easy to find. That's not going to be an integer for one thing, because 3 squared is 9, 3 cubed is 27, 3 to the fourth is 81, and then 3 to the fifth is going to be 243. So there actually is no rule for sums of exponents like this. This was a trick question.